All right, here's some select problems from the Chapter 4 quiz in Integrated Math 2 in 2021. First one I'm going to do is number 4. Okay, so on this one, it's asking if this is rational or irrational. And basically what we have on top, this is an irrational number, and it's divided by an irrational number. And we have a rule for that. Anytime that we have an irrational divided by an irrational, we know that it can be either rational or irrational. that's the rule, is that we just don't know what it is going to be. So it's kind of misleading because it's not really a rule. We have rules for rational divided by rational or rational times irrational that do work. But this is the one scenario where the only way we can tell whether it's going to be rational or irrational is by simplifying it and seeing what we get. So you have to actually do the work of simplifying this thing. And 108 divided by 3, well, you can do this, first of all. You change it to that. And 108 divided by 3 is 36. So this is the same thing as saying the square root of 36. And the square root of 36 is just 6. And 6 is a nice, neat, rational number. So in this situation, it becomes rational. So that's what we mean by it could be rational or irrational. It happens to be that this irrational divided by this irrational simplifies down to 6, which is a rational number. If I was to just change this, if I was to change this to like 109 divided by 3, well, that will not simplify to any rational number, so that won't simplify down to like a nice, neat number. So we could say that ends up being irrational, okay? It all depends on how it simplifies, okay? So this one simplifies down to a rational number, therefore it's rational. This does not simplify. That's why I kind of wrote this does not equal simple, but that's all I was trying to say is it does not simplify. And that's that. Okay, number 10 says find the zeros of this quadratic by using the quadratic formula. So simple, okay? We're just going to plug these things in the quadratic formula. So what's the quadratic formula? It's this. And I encourage you guys to like write this down on your 3x5 card. I don't have my Apple Pencil with me, so this is getting my hand used. It's already bad, and without my Apple Pencil, it's a little bit worse, so I apologize. So here's your A. That's really like a -1. That's your B. There's your C. So we'd say x equals negative 1 for B, plus or minus the square root, -1 squared minus 4, times an A. The A would be 2, times the C, which is also 2, all over 2 times the A, which is 2. All right. So as we simplify this, we get 1 plus or minus what's going on in the square root. Let's talk about it. So -1 squared is just +1. And then we have a minus, but 4 times 2 is 8, times another 2 is 16. So really this is 1 minus 16 over 4. Well, that means that we get 1 plus or minus square root -15. And they're both over 4. We can kind of do that. Well, what can we do with that negative? Remember, we can pull it out, so we can call this 1/4 plus or minus square root 15 over 4. And we could call that I, so we don't have a negative in there. So we're looking for something that looks like that, which looks a lot like that one to me. Okay, there's number 10. And let's also do number 14. 14, we're going to simplify this in terms of I. Whenever we're simplifying a square root, just like I just did, we need to pull out the negative, make it an I first. So the very first thing we do is we call this square root 405, and then we have an I on the outside. I often actually like to put the I in the front. It doesn't really matter, just as long as you don't put it inside the square root. Now, what multiplies up to 405? And specifically, what perfect squares multiply up to 405? Well, it turns out that you could do an 81 goes into 405. And so, yeah, it turns out that 5 times 81 is 405. So you could think of this as 81, or square root 81 times square root 5 times I. Well, the square root of 81 is obviously 9, so you'd write it as 9 square root 5I, or as I told you, it's usually best to put the I in between there just so you don't accidentally put it underneath the square root. Boom, that would be your answer. So you're looking for the biggest perfect square that goes into 405. After you pull the I out, step 1 is always pull out the -1 and call it I. Then from there, what's the biggest perfect square that goes into that? And then you simplify down. So that's how you do those ones. All right, that's it. Bye.